Yo guys, and we back for part two of the video. The first part of the video, we got to a solution that's actually not good for us. It is actually the right solution, but it will need a whole lot of computational power in order for us to actually get the result in a reasonable time. But I kind of did this on purpose. The question actually gives us a good clue on which direction to take. Sometimes things like this happen where you miss something and you try to get a solution for the problem, but it doesn't actually work out. Oh, it works out, but it's actually not an efficient solution, so it can't actually be something that you use on a daily basis because time is of the essence, right? One thing that we can look at in the problem, they're talking about prime factors, right? And we left out a key component over here, the factors thing. So what is a factor of a number? So if let me just show you something. So the factors of a number are the numbers that make up a number when you make up a particular number when you multiply them together. Like if you wanted factors of four would be what? 2 times 2. Those would be factors. That would be 4. So the factors of 4 would be 2, right? And so any number, actually, any number can be factorized into prime numbers. So any number can be made up of multiples of prime numbers, right? So that is the thing. So I'll show you just now. So if we have the number 10, right? 10 is essentially what? 5 times 2. 5 is prime and 2 is prime. Let's look at 20, right? Let's look at 20. 20 is the same as 5 times 4, right? But 4 is the same as 2 times, 2 times 2. So we can always get the prime factors of a number if we factorize a number. So that is actually the approach we're going to take in this video. So yeah, so I will remove I'll remove the first part. We actually don't need to take that approach anymore. So I will actually change the body of our code. So how are we going to do this? So we have a number n over here, and we want to get the factors of that particular number. So we can start off with our prime number, divide that number, right? We start off with 2, the lowest prime number in this case. So in the attempt to find the largest prime number. So you can start off with 2. If we divide n by 2, and it actually divides n by 2, then that we can divide the new number by 2 so that we exhaust it until we can't divide it by 2. Once we can't do that, then we'll search for if there's another number that divides the number that's left. Because like using this example over here, let me just show you some examples over here. So I have 10. I'll go 90. And then I'll go like 16, right? So 90 is 45 times 2, right? And what is 45? 45 is 5 times 9. So what is 9 now? 9 is 3 times 3. So we actually got the factors of that. So if we divide 90 by 2 from this side, so we're just trying to make these things equal, right? If we divide 90 by 2, we divide both sides by 2, looking at this 90 over here. So we'll essentially remove this, and because we've divided by 2, and this will be what? 45, right? Now we have three on the side. So we can't divide by 2 anymore, because if we divide by 2, we'll actually get a fraction. So now if we divide by 3, we'll remove this 3 over here, and then what will we get? This side will get 15. And if we divide by 3, we know we can divide by 3 because there's a 3 on this side. So we divide by 3, and then this side will be 5. And if we divide by 5, then we'll get 1. So we know when we get to 1 with our division, that means we are actually done finding the largest prime factor. So if by looking at that, what I just did now, so we can already see that 5 is the largest prime factor of 90, right? So that is the algorithm we'll be using. Let me just take that back. So what do we need to do? So we need to divide the number until we get to 1. And how do we make sure that we do that? Like, we move from prime to prime, right? So what we'll do, I'll show you what we're going to do now. So we know that while we're dividing and the division is greater than 1, right? Then we'll execute some logic in the code over here. So what are we going to do? So we have our number over here. So I'll assign a limit in here. So I'll assign the limit in here. So I'll assign this limit to n. And then what do we need to do? We need to divide this limit over here. This is the guy that will be changing. So to start off with here, we know we had it as 90, and then we divided it by 2, and then we had it as 45. So this guy will start as 90, go to 45, go to 15, and then get to 5, right? So that's why I'm assigning this guy over here. So yeah, so what are we going to do now? Our limit is going, so now we need to divide our limit by our largest prime, right? That's what we're going to do. And while this division is greater than 1, we execute some logic here. So what do we actually want to know? So we want to know if we can divide our limit by the prime number that we have. If we can, then we assign. That's what we're going to try and do. So in here, if our prime actually divides our limit, then we want to do something to that thing, right? So we want to change our limit to be, so we're going to divide our limit to get the new limit. So if the limit mod our prime is equals to 0, what do we want to do? We want to divide our limit by our prime to set the new limit, right? So now our limit will be, so I showed you the syntax, the plus equals syntax. You can actually use the divide equals syntax as well. So yeah, so this is what we're going to do. So now we have our new limit, right? Once we have our new limit, we can add this. So now let's go through the code. We start off with 90, and then we assign our limit to 90, right? And then after doing that, we check if dividing our limit by our prime is greater than 1. And if that's the case, that means we can try and find other primes that make up our number. So we're factorizing our number. So now we're going to check, okay, does this prime actually divide this? Because this might be the case, but what if this is 1.5? This would be true, but you can't actually divide it. In this case, you won't be able to, right? So after that, what do? We actually, if we can't divide our limit, that means there are no more factors of this largest prime in our number. So what do we want to do? We actually want to move up and in search of our next prime number, right? So also else what do? We can increase our prime by 1. So why are we increasing our prime by 1? So we're increasing our prime by 1 because we want to search for the next prime. So we already know that. So let me show you the example with no, there's a 2 missing over here. Let me show you an example with let me put back the 2 times 2. So let me show you with this one. Let me show you with the 20. So if we take the 20, right, and we divide 20 by 2 to start off with, we'll divide 20 by 2 here, and then we'll be left with what? We'll be left with 10. Then we'll come back, divide 10 by 2, right? So after that, we'll have 5. And then we'll try and divide 5 by, we'll see that, okay, the limit will be 5, the largest prime will be 2, and you can't actually divide that. So it'll come in here, increase it to 4. But we know that you can't divide it by 4 because we've already exhausted all all the 2's, so it can't be divisible by 4. So it'll not go in here because we won't be able to divide it by 4, and then it'll come back in here and you increase it by 1 and it'll get to 5, and then after that we'll divide it by 5 and it'll be 1, and then we get 5 as our answer. So this is why this solution works. So yeah, this is a simple solution. Way simpler than the one we looked at in the previous video. So let's test it out. So TS node, look at that. That was like super quick. So yeah. So now let's actually go and test it out in our browser. I'll just do that quickly. Let's test it out. And that works. So yeah. So if you have any question, let me close this. If you have any questions, please comment down below, and I'll be happy to answer the questions that you have. So yeah, let's go.